So today we are going to solve the problem array description. You know that an array has n integers between 1 and m, and the absolute difference between two adjacent values is at most 1. Given a description of array where some values may be unknown, your task is to count the number of arrays that match the description. Okay, so what we have to do here? Let's start with the problem. What we are given an array which consists of n integers, and this integer can go from 1 to m. Okay, so what we are given some integers, and some spaces are blank. So we can put some values here, but the condition is no two adjacent elements should be, the difference between two adjacent elements should be less than 1. So for whatever value we can put, but the difference between adjacent elements should be less than 1. So suppose if we put 1 here, then it is not valid, because if we put 1 here, then it is not valid, because then the difference between these two adjacent elements would be 2. If we put 2 here, then yes, it is valid, because adjacent elements have difference 1. Now, if we put 3, then also it will not be valid. So here the only valid case is 1. So we have to find out how many valid ways are there, how many valid arrays exist. Now suppose there were multiple zeros. Let's suppose there was 2 zeros here. It's 2, 3, and 5. So how many ways here? So we can't put 1. We can put 2 here, and 3 here. No, this condition will also be not valid. So we can put 2, 3 here, 4 here. Then we can put 4 here, 4 here. We can put 4, 5. Okay, so there are 3 valid ways. Okay, so this is the question. We have to replace the zeros, and we have to find out how many arrays we can form that satisfies the condition. So how can we solve this? Suppose you can see that the value which can be put here at any 0, if it has a value, then we can't do anything. But if it has 0, then how many ways can we fill? It depends on the previous element only. If suppose if we have previously it was 2, then we can only put here 3, 4, and 5. Sorry. We can only put 1, 2, and 3. Suppose it was 3, then we can only put 2, 3, and 4. So it only depends on previous value. So if the array was 1, 2, 2, 0, and 5, 5, 5, 0, then this depends only on previous one. If it was 2, it was 3, and it was 4. Then although these elements are different, but the case here would be same. The answer would be 3. So we can see that it only depends on previous value. Now suppose if we know the value for previous element, suppose we are at ith index. Okay. So what can be the possible ways we can get it for the ith index? Suppose if we know for I minus 1th index, suppose if we know every value for I minus 1, what would be the answer if we put 1? What would be the answer if we put through? Similarly, 6, 7 up till m we know for every value. Then we can find for ith index if it is a particular value, suppose say 7. Then we can simply add the I minus 1th value for 6, I minus 1th value for 7, and I minus 1th value for 8. And if it's 0, if the ith index is 0, then we can assume that, let's suppose, if what if we put 1 here, what if we put 2 here. So we can check for every value, and for a particular value we can follow the same steps, that is check for I minus 1, j minus 1, I minus 1, j, and I minus 1, j plus 1. Okay, so we can get this way. So now at last we will know for how many. At last we would know for each element what would be the answer. For 1, what would be the answer? For 2, 3, similarly till m. So at last what we will do, we will simply sum all from 1 to m. This would be our answer, right? Uh, if we look it in a recursion way, as I told you, you have to start visualizing it directly in the table, in tabular form. Means you have to look it as a states without even writing the recursion. Now for recursion, what we can suppose, we have to find a, we have to, this is the array 2 0 1 2 0. Yeah, we have to find for this. So we are at ith position, 0th position. So how can we find for 0 when the value is 2? So if we know the answer for 1 comma 1, 1 comma 2, and 1 comma 3, if we know the answer, then it is simply the summation of all three. Okay, so it would be like 0 comma 2. From here we can go 1 to 1 and 1 comma 3. Now the next element is 0, so we can put anything here. So if it's 0, then everything is, this also depends on, so we can put 1 comma 1 here. So it will depend on 2 comma 0, 2 comma 1 and 2 comma 2. If we put 1 comma 2, then it would depend on 2 comma 1, 2 comma 2, 2 comma 3, and it will depend on 2 comma 2, 2 comma 3, and 2 comma 4. Summation of this. Now this element is 0, so we can actually take every element. Now the next element is 1. So if there is a value present, then it would be 1. It would be followed, but this would be directly 0 because that value is already present, so we can't put anything there. This would be also 0. This would be also 0. 0, 0, 0. So now the only possible way is 2 comma 1. From here we can go 3 comma 1 and 3 comma 2. But in third element also the element is present. So this would be 0 and this would be again divided 4 comma 1, 4 comma 2, and 4 comma 3. Now it is 0. So it can form this 3. So we can return 1, 1, 1. So it would be 3, 3, 3 from here, 0 from here, 0 from here. The answer would be 3. And if you see, sorry, from here also, it will follow the same answer. So 3. So it would be 6. Total answer would be, my mistake, it would be 6. And from here also, you can see that we can put here 1 here, 2 here, and we can put 1, 2, and 3 here. So 2 into 3, 6. Okay, so this is how the recursion would work here. Now, as of we have to write the code, let's start. So, what are the states we would require? We would require 2 states. What is the correct index? What is the current index? And what is the current value we are looking for? Now, if current index is out of the array, means we have reached the end, greater than or equal to size of array. If current index is greater than or equal to size of, we will return 1 because yes, we have reached till the end. Now, if value at ith index is not 0, so it has some value there. And if it has some value there and that is not equal to the jth, means what we are looking, and array of 9 is not equal to j, then we can return 0 because it is not possible to do that. Now we can start answer. We can go to next element and check for j minus 1. We can go to next element and check for j and j plus 1. And we can return that answer. Now it will require us to calculate the same states again and again, like 2 comma 2 here, then 2 comma 2. We are calculating the same states again and again, so we can memorize it. You guys now know the method for memorization. Define a DP of n comma n. Now we can write that if we already got the state is not equal to -1, so it is already found, we would return that. And at last we can first store it in the value and we can return. So done. This is our memoized code. It's good to write the memos, but now if you are really trying to excel, means you should be able to think this quickly. Like without writing this code, you should know that what are the states I require, and you should be able to directly write the tabular form. So in tabular form, Let's first write what. Now let's first define our base case. So should be something like this. Then for base case, we can simply calculate for this one, and from this we can calculate every other because we just require previous state for the current state. So for base case, we can calculate for the single one. If the first element is zero, then every element would be possible. So j from every element would be possible. So if first element is zero, then everything is possible. So j can go from 1 to m. So everything would be 1. And if it has a particular value such as this, then only that j can be possible. So only that value would be 1, other everything else would be 0. And for the rest of the part, we can calculate it. Now for let us write for the base case. So if array of I equal to 0, array of 0 is equal to 0, or array of 0 is equal to this term, then only we can say that dp of 0 comma iota is I is 1. Okay, so this is our base case. Now for every other element from I equal to 2 to I equal to n, I plus 1, simply dp of I comma, here also for every j from 1 to n. Can calculate it by three values. So this is the case, and at last we would return now at last we would return the summation of everything. It should be a tabular. So the time complexity for this would be we are looping to n and n. So it will be n into n. That is 10 to the power 7, which is like equal to 10 to the power 8. So it would space complexity we can uh, optimize it to currently it is n into m, but we can optimize it to m because we just need two states, current and previous, so we can eliminate everything else. Oh, one more thing. If this is the case only if You would only update it. The current I is 0, or if the current I is equal to I. Okay, so this is the code. That's coding. And that's dependent register. This would be our DT. Definition number of ways to fill the life index. Current element is 0. Current DP or the previous DP. I'm writing directly the space optimized one. And let's just define the base case. That is if it's 0, then we can put anything. Previous DP I will be 1. And for the start DP. DP of 1 plus 1 is 0. And current DP of I plus equal to DP of I minus 1. Previous DP of I plus previous DP of I plus 1. We have to know DP because it can we can define it with n plus 2. That way we can avoid the checking for if it's valid or not. Because I minus 1, that would be in worst case 0. So that is also already present in our vector, and I plus 1, that can be m plus 1. So now that is also present. And by default it will be 0. So that value will be not base calculated here. And we can swap 20 previously. At last, our answer would be previously given. 1 minute. Oh, that's that. Stage. 1. Two mistakes. Still preview of 500. So I think yes, integer overflow. You can do this just 3 times. As you can see, it conducted. Thank you guys. See you in the next video.